And now for Intro to Blue Team by Max, Green, and Luke. Make sure you guys stand behind the cameras.
Hello, everybody. Today we're going to be presenting on Intro to Blue Team. All right, who am I? I'm Luke Demi. I'm a third-year BSM cybersecurity major. I'm a Christian. I also interned at New Harbor Security this summer. Did basic cybersecurity work for them. I'm a part of the Windows CCDC team and the RIT Red Team. I love doing outside activities like skiing, bowling, and fishing. I might be Wendy's top customers. I love national parks. I am in hibernation. I go to the gym a lot. And I play too much Clash Royale, as a lot of people know.
Hey everyone, I'm Max. I'm a third-year BSMS honors cybersecurity. This past summer and right now, I'm a cybersecurity intern at Delaware North. I do analyst work over there. I'm a bassoonist in this semester the RIT Philharmonic Orchestra. I'm a math and science tutor at Bates Study Center in Gosnell. The Yankees control my life. I get a little break, sadly. I'm a caffeine enthusiast. I love my energy drinks. I'm going to grab one after I give this presentation. I'm on Red Team, from Long Island, love Taco Bell, chronically late to everything, and I enjoy going to the gym.
Hello everyone, my name is G. I'm also a third year CSEC BSMS, co-opted AWS, do networking for CCDC, big fan of the arts. Please give me museum and gallery suggestions. Love to cook, and I finally beat Silksong, so of course I'm now craving the next game, which will probably take like 7 years.
All right. So what is a blue team competition? I know a lot of you guys have IRSEC coming up, so it'd be important to pay attention. So red versus blue competition pits teams of defenders against teams of attackers, red team. So you'll be defending all of your services against against red team. Blue team's given a network of systems to maintain and keep functional at all times. And these services are scored through checks, usually every minute or so. And red team will be trying to take down all of your services. You also, during this competition, it's not purely based on uptime. You also have injects you'll need to do. And these injects will be given to you by white team, and they will have different tasks for you to accomplish for your CEO, who's going to ask you to do certain business tasks. So what do you actually do during a blue team competition? You fill in a bunch of different roles during that. You can be a system administrator, auditor/threat hunter. You can be an analyst. You can be an incident responder. You can be an engineer. It combines a lot of different roles you'll see in the real world, and apply them to a competition. Depending on the competition, red team pre-bakes. For IRSEC, red team will be pre-baking, but it doesn't really matter because it's your job to keep it up anyways. All right, so the competition plan. I don't know if any of you guys have gone to iRig, but they do a really good job of mentioning this. Have a 5-minute plan ready. The first 5 minutes, it doesn't have to be 5 minutes. CCDC's 5-minute plan is like 5 hours. But try to have as much done as possible in advance. If you really want to do well during this competition, you want to prepare for it. So you're accessing your sister systems and obtaining tooling, gathering information about the systems, rotating passwords. Try to rotate your passwords as much as possible because there's a chance that red team already has them. Make sure to harden your systems and services. This includes putting up firewalls, setting up logging, configs, backing up configs, etc. In threat hunting, we're going to go into a lot of the tools you can use for threat hunting later in this presentation. But for now, just keep that in mind. Incident response. At the end of IRSEC, there'll be an incident response report for you to do. So make sure to keep track of all the things you find from red team on your system, because you'll need to write a report at the end on everything you find. It is great to have screenshots and evidence that it happened. And finally, index. Like I talked about earlier, you'll be given business objectives. All right, so moving on to the Windows. This is a general overview of everything you need to know during Windows. If you want to know more, I think we have a few more workshops with CCDC as well. All right, first of all, system access, starting off very simple. What account should you use? For domain controllers, use domain admin. Everywhere else, you should use local admin. This is principle of least privilege, preventing people, or especially red team, from having accounts they shouldn't have accounts. So you can access using the GUI. And there's a lot of remote access options. but it's best practice to turn it off if you don't need it. So RDP. Oop, sorry, do you have a question?
Yeah, I know this is an item for.
Yeah.
But what do you guys think of that assignment time? Because personally, I think that after the break, for choice.
I'm not gonna repeat the question.
Lapse that local administrator.
You want to answer this? I actually want to
Yeah. Repeat the question.
Oh. The question was how effective do you think LAPS is? It's good. The cloud version is better. Modify something like that. They don't really use this, but it's not really applicable in a competition just because you're on like you all the administrators. And for those who are not familiar with LAPS, it's basically a solution where you're not going to give your end users in your business local administrators, but you as a system administrator need local administrators to be able to fix stuff on the machine. So it's a solution to store the passwords for the local administrator on the machine, so that whenever you need to, you can log into that local administrator account. And one way to do that with Microsoft Active Directory, LAPS also offers through Enter ID, which is a better version because then you just need to go to the website to do it. You don't need to log into the domain controller. And then most likely it's better than I.
Going back to remote access, so there's a couple different ways to do remote access on Windows. First of all, the most important one is RDP. RDP is used to have a GUI access to your system, and Red Team will abuse this because there's lots of ways to use RDP in order to get into your box without you knowing it. Secondly is WinRM. It's a funny little Windows protocol that allows you to run commands remotely, most commonly used with Ansible. But yeah, make sure with all these services, make sure if you don't need them or if it's not a score check, turn them off if you can. Because that's a really good way Red Team will use to get into your systems. Also SSH, it's an optional Windows service, but it's common on competition machines because again, Red Team likes to use those. All right, so what is a Windows service? A service is a process that's running in the background, and this is different than a scored service, which is interesting to mention. Red Team loves using malicious services. For my tool I built on Red Team, it has a malicious service. You might want to look out for that. And this is built-in persistence, and it's very hard for beginners to kill. So you have to go into services.msc, and there you'll find services that automatically start up on reboot. So even if you restart your entire box, it'll still be there running in the background. And there's the services GUI, which you can again use services.msc. It's also through PowerShell. PowerShell is really good at being able to detect services. So get service command line is really important as well. All right, so moving on to the common scored services. First of all, Active Directory. The scored service for this will be LDAP, and DNS also would be on the Active Directory domain controller. So make sure to research a bit about LDAP and DNS beforehand. LDAP is the database querying protocol, and DNS is used to map IP addresses to human readable domains. DHCP, it's not usually scored in competition, but sometimes it has been in the past. It's used to assign IP addresses to hosts on a network, so they do not have to be configured statically. So it's giving a new IP every single time you connect to the. Also SMB, this is a common service for IRSec. I'm not sure if it's on it this year, but it's file sharing. So if there's some file, being able to share it on one network that's scored. IIS as well. It's Windows version of a web server. Like this again, you can it's either an HTTP, HTTPS, or FTP check on that. And finally, WinRM, as I mentioned earlier, it's a remoting protocol, but sometimes you need to keep it up because it is scored. So yeah. All right, moving on to some Windows features. Windows Firewall. Windows Firewall will be the most important part of your competition. It can either make your competition go really well or really badly. The firewalls are usually goated, and it's an easy W for teams blocking new connections. As you can see in the image, this is us at CCDC last year, and we were this team right here. And that's what happens when you have a functional Linux firewall for the first time ever. So it just shows you how good it is to keep Red Team out if you have a functional firewall. There's 3 different profiles: domain, public, and private. So make sure to pay attention to all of those. And they have logging settings as well. If you really want to get into the logs of firewalls, they have logging settings. The rules can be set via the GUI or the command line. And yeah, firewall scripts. If you want to do anything before comp, make a firewall script. Just make sure you test it before it and make sure it doesn't lock you out of the service or out of your box. That's an issue as well. All right, for group policy, Active Directory has the ability to make group policy. Also, you can do local group policy on computers. But yeah, there's definitely going to be an inject in the competition, or not definitely, but there has been most competitions of developing a group policy for your domain. So make sure you experiment with that beforehand because you're going to need to know how to do that. You can enforce policies using GPU update force. And each set rule can be found in the registry, which we'll go into a bit in the next slide. But yeah, it's used to enforce configurations and settings across a system or domain. So it's used for just general group management purposes. All right, the registry. I'm not going to go too deep into the registry because it's really complicated. But basically, it's a database that controls everything on your system, pretty much. Everything. It allows you to configure values related to almost everything on Windows, like users and applications. And you can view it using regedit. And this allows you to modify values stored within the registry. And it's very much used for hardening purposes. There's a lot of registry keys that can be misused, especially by Red Team. And they allow you to get into the system. And you can use through the command lines. You can use reg commands such as regadd, regdelete, regquery to find use malicious or just general hardening if you need a general hardening. All right, securing users and groups. This is one of the most important things to do during comp besides firewall. A lot of users have properties which can get used. And it's best practice to disable unneeded and unauthorized users. Now you might be asking, why don't you just delete them? Like I mentioned earlier in the competition, you have an II report at the end. So it's best practice to keep them on your system, but just disabled, so you can take screenshots or have proof of it later. Because in a normal environment, you wouldn't just immediately delete them. You have to show proof to why you delete it. Make sure to audit group membership. Obviously, if there's a user called Red Team on the box, you shouldn't have an enabled user. Here's some other useful commands. A lot of this is group querying and potentially making or removing users as well. And then you can use LUSR manager.msc, I don't know if I pronounced that actually, but it's used to audit local systems, and DSA.msc, which will audit remote systems. Is it actually?
L user.
Oh, I'm dumb. Okay. Yeah, it's local user manager.msc. Yes. All right. Rotating passwords. This goes hand in hand with securing users. Your credentials are compromised from the start. Red Team knows your credentials because it's in the packet. So you want to change those fast as you can. That should be one of the first things you do in the competition. Passwords don't just exist for the system users; they can also exist for services and applications. So a lot of, if you're especially on Linux, it's doesn't apply here, but services do have passwords as well. So make sure to change those and make sure to update those in support checks as well. You might have to change a password multiple times throughout the competition. In fact, we recommend you change your passwords multiple times throughout the competition because, again, Red Team has those passwords. It makes it more of a nuisance for them. And yeah, don't use the GUI for passwords. It's really inefficient and not helpful. Just use NetUser. It's very easy and it gets done really quick. All right, threat hunting. Threat hunting is searching for malicious behavior in the system. This is what you'll be doing most of competition during IRSec. So it's searching for abnormalities. Because Red Team has lots of persistence on your box. It'll be running very slowly because there's so much stuff running on their box. So there'll be, for example, there'll be starter programs, scheduled tasks, run keys, and shims, all just ways that Red Team keeps persistence on the boxes. They also abuse misconfigurations of services. There can be malicious DLLs, malicious services, like I've explained before. And yeah, all of that will be on there. In the next couple of slides, I'll give you some more important tooling you can use to try and find these threats in the system. So the most important Windows tooling will be system terminals. System terminals has so many good tools. that help you threat hunting. So make sure you play around with these before comp. That's another important thing you want to do. First and foremost, will be auto runs. Auto runs is the best. Auto runs is able to detect auto start locations. And this includes in the startup folder, the registry keys, the scheduled tasks, services, WMI, all these different places. It's really good for detecting auto start. So if they have something automatically running in the system, auto runs will catch it. I don't think I've been in a time where it hasn't caught something. It's very helpful. Although there are some locations that don't monitor. Yes, you have a question?
What are the it's not common Linux, what are the auto start locations on this?
Windows? Right there.
We'll take the question.
Oh,
Like
where do they start on Windows?
yes.
There's certain registry paths, for example. I don't know the exact path. It's very long. What?
Just all of them right there are
Yeah,
auto run paths.
Those are all different places they can automatically run from boot. So make sure you check there. There's a couple of registry locations as well. Like I don't know the exact path again, but watch out for those. Not every location is monitored, but a lot of the auto start, actually pretty much all the auto start locations are monitored. Also look for the random binaries. They will pop up in red. It'll be very obvious if it's safe. It'll be bright red. So yeah. All right. Another system internal tool is called Process Explorer. This is able to examine all the processes running on the system. It's basically a better task manager. So I wouldn't use task manager. I would use Process Explorer. And it shows detailed information about process running on the system, including the process ID, the owner, different command line arguments it might be using, the process tree, some more loaded DLLs. This is really important for determining if this is a fake or malicious service. It'll be pretty clear, at least I think, if it is a malicious service because it'll have a lot of these things that they won't be correct, like a normal service will be. But yeah, look for random running processes. Also, again, this will be popping up. It'll be flashing, like it'll be flashing red. So it's usually pretty clear if something's malicious on this. Process monitor. This is a bit more complicated, but it's real-time monitoring the file system, registry, and process operations. It's really helpful for spotting malicious activity, but it's not as beginner-friendly. It's listing literally everything happening on the system, so you have to know how to filter through the logs to find stuff. So yeah, it's a lot of fine-grained filtering, including registry key values, processes, process IDs, etc. I know there are some examples out there, things you might want to look for. There's online documentation of things you might want to have as a filter if you really want to use this tool for a while. Also, TCP view. It's like netstack commands, so it's able to access or enumerate all active TCP and UDP endpoints. It gives, again, process name, process ID, protocol, the local address, remote address, creation time. And it refreshes every second by default. So if red team has a connection to your box, you'll know instantly through the TCP. Yeah, make sure to look for those weird ports and programs. All right, finally, Sysmon. Sysmon is just event viewer, but better. So Windows Event Viewer is a way to view logs for all your systems and services. So this is a better version of Windows Event Viewer, and it's built on top of it. So you can, using that file path on Windows Event Viewer, you can find all the Sysmon logs. And it's important to look for this. There's different events that might be important, such as process creation, network connection, image loaded, create remote thread, file create and registry events. And these are all things that could indicate red team activity on your system, and this will be able to catch it. And yeah, just going back to logging, the Windows Event Viewer, you can be accessed with Event Viewer .msc, and it logs four different types of logs: application, security, setup, and system logs. But yeah, like again, Sysmon, it's a better event viewer, so I recommend using Sysmon if you can. And it's super helpful for troubleshooting when a service goes down. For example, I use it all the time for IIS. IIS is kind of complicated to figure out what's going on when it goes down. If you go into logs, it'll be very easy to figure out what is going on. So I would highly recommend using this tool. Yeah, make sure to look for suspicious network connections and application names. All right, got some final useful commands you can, I guess, take a picture of if you want before you leave. But yeah, next stack, again, I would recommend using TCP view instead, but if you want to just use purely command line, this is important. ID config, net share, that's especially important for networking, get net TCP connection, get net UDP connection. Again, TCP might be better in my opinion. Get process, get service, get net firewall rule, and get single path. If we want it for threat hunting purposes. All right, that's up next.
Now it's time for everyone's favorite part of the presentation, Linux. So why should I care about Linux? You might be asking. You should care about Linux. I don't think it's crazy to say that in any blue team competition, Linux machines will account for probably most of the boxes you're going to see. Whether it's Linux servers, your router is probably going to be Linux based. Your Windows might have Linux. Everything has Linux. So
Yeah, in Windows we have Linux like on box.
yeah, so Linux is very important, and you should care about Linux. In both in competitions and in real life, many services are hosted and run on Linux or Unix operating systems, and if these are compromised, you'll get very easy downtime. In a blue teaming competition, everyone on your team should at least be a little bit familiar with navigating around a Linux environment. If you're cybersecurity, you'll take 140. I think you get a little bit of stuff with Linux command line there. You'll get a lot of stuff with your networking classes. Learning how to navigate a Linux environment will be super helpful during a blue team competition. So for Linux, what your first 5 minutes should look like, as soon as your hands are on that keyboard, you should try to aim for easy fixes with big impact. So this might be changing passwords. Please change your passwords. Red team gets the exact same packet as you, and you don't want them to get in that easily, because if they're looking at the same packet and they see that, oh, this user's password is pass154, that's the default one. They just can log in with that. They have access. And if they have access, probably not good for you. Backing up important files, this is just generally throughout the competition, but you should do it in the first couple of minutes. Backup files that you're going to change before you change them, just in case that your changes backfire on you. Backup critical service files in a secure location. Backup anything that looks important. If there's a file that you think could be associated with a score check, should probably back that up somewhere that red team can't find it. And during these first 5 minutes, trust me, things will go wrong. But you have to keep moving forward. Don't try to get stuck on one thing and not forget, but leave other things just because you're trying to get this one thing that's not going right. Because red team gets access to the boxes before usually in most blue team competitions. Things will be broken from the start. You don't want to get caught up trying to investigate some red team tool while you still have default passwords. So there's been IRSec blue teaming presentations like workshops past couple of weeks. I went really in depth on all of these services during. Oh yeah, sorry. Question.
Is there a place where should you have with the files?
A location where red team can't find them. So it should be your own special location. Oh, sorry. The question was, where should I back up those files to? And the answer is just a location where you know where it is, where it might not be obvious to red team.
So, for example, for CTC, we do not put this in our script. It's obviously for public on the internet and red team stuff. I'm going to find your script, or we type in that location. It's like manually the day up. Like each year, like last year, we see program data epic.
Yeah, awesome. But common Linux services that you might see during competition. I mean, I don't know if the IRSec packet is out yet, but if you're doing IRSec, those are going to be in that packet. Yeah, but some services you might see are SSH as a scored service, FTP as a scored service, HTTP or like a web service as a scored service, SMTP or IMAP, mail services as a scored service, databases as a scored service, and Docker can really be used to host basically anything in a container. Your scored service might be in a container, so it might be useful to get to know how to work with Docker. I know during IRSA it was probably going to be Docker. Again, if you want an in-depth, in the IRSec blue teaming workshop, I go over like where the config files are, some like security things. So those are in announcements if you want to scroll back up and check them out. But in general, for blue teaming services, you want to most importantly learn what the score check does. If red team knows what the score check does and you don't, they can use that against you. So try your best to figure out what that score check does within the first maybe like part of the competition. And some changes that you might think are secure are going to break the score check. So really know exactly what it does. Again, change default passwords. For a lot of RIT competitions, if you change a password that's used in a score check, you have to update that in Scoreify. That'll be gone over during RSEC. But if something like that is required, look into that, because if you change the password on the host and don't change it in the score check, it's going to keep trying to log in with the old insecure password, and your score check will stay down. And logs are your best friend. Make sure logs are enabled on all your services and you check them out, because that could tell you access, that could tell you errors, that could tell you a lot of cool stuff. And on Linux, most logs are in /var/log. Linux user and password management. This is where I've done a little bit way too much research. Everything in Linux is a file. If you think it's not a file, it is a file. Literally, whether it's a fake file or a real file, everything is a file. Some important files for users and passwords specifically. Etsy password is where you're going to find basic user account details and shells, username, what shell they log into when you log in, home directory, stuff like that. Etsy shadow are going to store the user password hashes. Etsy login.defs are going to be where you find default user creation and password rules, like password complexity, length, stuff like that. Etsy group is where you're going to find group definitions, memberships. Etsy suitors are where you're going to find sudo permissions about how you can log into admin. You edit this file with vsudo, just the command is vsudo one word. And /var/log/auth.log is where you're going to find authentication logs. Successful logins, unsuccessful logins, stuff like that. There are some commands that alter these files for you. I recommend using these commands because if you try to edit them yourself, you might mess something up. Usermod modifies property of user account, and password changes the user password. There's also ch password, which has a similar functionality, just different execution. PAM. All Linux since probably 30 years ago use PAM as their authentication modules. PAM stands for pluggable authentication modules. They were created as basically like a solution to modularly enable different kinds of authentication on Linux. Different distributions use different versions of PAM. Most Linux distributions use Linux PAM. FreeBSD uses OpenPAM, but they do the same thing mostly. All service/system authentication goes through these PAM modules in some way, and you can configure which modules to use and how to use them in etsy/pam.d. Yeah. And there's this cool graphic about how these PAM modules are loaded. Yeah. Linux firewalls. Linux firewalls are more or as important as Windows firewalls. How firewalls normally work, you can create rules to block and allow different network connections. Some high-level firewall tools that you can use on Linux are going to be UFW or uncomplicated firewall on Debian-based distros. Some example commands to enable the firewall, allow certain ports denied from a IP address range. Firewall D or firewall daemon is going to be on Red Hat. So it's going to be like longer commands, but they accomplish the same thing. For low-level firewall tools, if you want to get granular with it, there's going to be IP tables, which is going to be default installed on most Linux distributions, I think. And then there's NF tables, which technically exists as a more modern replacement for IP tables, but it might not be installed by default. Linux hardening. Secure configurations are your best friend. Red Team can exploit these insecure configurations and maintain persistence. So look into some system and service security. Look into services on the network, where their configuration files are located, most likely in Etsy, and how to secure them. For example, you can set permit root login to no in Etsy sshd_config to disable SSH authentication with root, which you might want to do because you don't want Red Team logging in as the root user. And look into like system hardening, like changing default credentials, auditing the Etsy sudoers file, getting rid of unused services, especially remote services that you don't need. If you have LAN access to a box, you probably don't need SSH as a server as a service. And yeah, update back. With Linux reconnaissance and audit, at the beginning of competition, you want to familiarize yourself with the infrastructure you have and the machines that you're working on. To run an initial audit of the various like important locations in the machine, find your SSH keys, which are going to be in the home directory .ssh authorized keys. Those are going to be authorized keys that are allowed to log in as that user over SSH. and there's a similar location in the root directory for the root user. See what ports are open on the system. Using SS or NetStat's kind of deprecated. So use SS to see socket connections, or Nmap if you really want to get fancy with it. See running processes with PSFox. Adding an F will list pair processes, so it's super cool to look at. Look at running services with systemctl, list units type service, state running. Look at schedule tasks. These are all going to be like your cron directories. There's a bunch of them. You might miss one or two. And users and groups in etc password and etc group. You have to know your system better than red team, because if they know better than you, they can use that against you, like I said earlier. Fronting. Here's a really nice persistence map that's very blurry, but you can see it better if you look at the slides later. But again, like Luke said earlier with Windows, you're probably going to spend like a lot of like the middle of the competition just like hunting for red team tools and hunting for threats. You want to regularly audit the system for new malicious activity. You can look for binaries and files that might not be installed by a package, maybe red team dropped in there. You can use debsums on Debian-based distros or RPM Tech QF on Red Hat. Investigate suspicious network connections. You can see which processes are associated with specific services down to a port, and maybe that service might not be critical. Check files that are run on login/logout, like .bashrc, etc profile, --logout. Check for rootkits and malicious modules. You can use lsmod to list loaded kernel modules. It might not be there. Rootkits are pretty hard to find, but that's important. And just some useful fronting commands. You can use W or who to list current terminal sessions and check for logged in users. So maybe you might want to check that out and end certain sessions that aren't associated with you. Kill TAC9 with the PID or the process ID will just end that process with the given process ID. And you can get the process ID from PSOX. TCP dump, T-Shark, NetHogs, Wireshark are all tools you can use to analyze network traffic on Windows. If you're heard of TMUX, you can use TMUX to open basically a terminal session on top of your current terminal session. So let's say you want to open a TMUX window, get TCP view running in there, and you can detach from that session, just have that running in the background so you can analyze it later. And strings. If you find a binary that might be suspicious, you can strings it, see if you find any strings that could lend itself to being suspicious. And up here, take screenshots of everything. I'm going to get into incident response later, but you want screenshots of all malicious activity you find, because that will help you a lot on incident response. Troubleshooting. This is at least my final slide. Why is my service down? That is the question you will ask yourself a lot during a blue team competition. Is the service turned off? You can try systemctl start service, and if it starts, maybe it just got turned off. Maybe red team did, maybe you did. I don't know. Is the score check being blocked by a firewall rule? IP tables TACL you can use to view current firewall rules. Is the service erroring on restart? You can check your logs. Journal CTL TAC XEU service will list logs for that specific service. Is some part of the score check erroring? Maybe a missing file. Use your backups. Know what your score check does, so you know if you need to restore a file. Always have a method of getting root access to your machine, because if somehow authentication breaks in some way, your box might be bricked if you can't log in anymore. But if you have a root shell open, you can probably edit whatever happened to lock you out. And if you don't know if it's malware or not, you can Google what you're dealing with to see if it's expected. Maybe it's like you're looking at like Whoopsie or something like that on Ubuntu. Maybe you think that's malware. You looked it up and you see that, oh no, that's how it sends logs to Canonical. So yeah.
Hello, everyone. Welcome to the best out of the three, networking. Networking blue team is pretty broad. So for this presentation, we are only going to go over pfSense because that is the common router appliance used here at RTSEC. But pfSense is a router appliance. It just basically puts a bunch of PHP files on top of FreeBSD Linux and hosts it on Nginx. Fun fact, all of pfSense system files are open source on GitHub, so you can look at what the defaults are. It's a really good way to see if a file has been maliciously modified I like to grab files here all the time and put my own little backdoors in them. And it's also a good way to learn how the PFSense system works. So with Windows and Linux blue teaming, a lot of your focus is going to be on the services hosted on those machines. However, if you are fulfilling the networking role on your team, your focus is going to be analyzing network traffic, and you are the point of contact to let your team know if there's anything suspicious going across the network. pfSense provides a really easy command line tool to do that called Easy Rules. You can block traffic, add an allow rule, configure it via interface protocol, and source and destination IP addresses. Note that you can only add rules to the system. This method, if you want to remove them, you have to go into the GUI, unfortunately, unless you're using a PF, which is a more granular tool as opposed to Easy Rules. And note that these are only applied at the router level. So like I said, pfSense is built on top of FreeBSD Linux. You also need to set host firewall rules either through IP tables or NF tables. And just as Max just reiterated, to reiterate him, everything comes back to Linux. Yes, you're going to be managing all the network traffic and you're trying to secure all the interfaces, but you need to check who's logging into my router. Where are they logging in from? So the who or last command shows you who's logged in and what terminal ID they have. And if you're like, that person's not supposed to be logged in, you can do pkill tac9 tapt to kill all processes associated with the terminal, which essentially kicks them out. Look for scheduled jobs in etc cron tab, and /var/bool/cron. Look for rootkits. Those are the two most common directories, but there are other methods. You're going to be auditing and doing inventory as part of your initial plan. And fun thing about FreeBSD is there's this directory /etc/rc.d. Any script in this directory automatically gets run on startup. So if you see something weird happening when you restart your router, which hopefully is not happening a lot, but might want to go check in this directory. So some common breaks and fixes. All your traffic is getting blocked for no apparent reason. None of your team can access anything. There's probably a default drop all rule. So you can go into your GUI. I'll show you where all the firewall rules are configured in a bit. But if you can't access the GUI or ping an interface, check if it's down. So I have config. And packets are getting dropped, but all your firewall rules are good and the interface is up. There's something called the maximum transmission unit. Thank you. Which basically tells the router how big can a packet be in bytes for it to be processed. The default value is 1,500 bytes. If it is an unusually low number, anything bigger than that will automatically get dropped by the router. So I would check that value. Now, as much as I love the pfSense GUI, it is extremely insecure. So I do recommend using the command line. There's some advanced techniques. Who has been to CCDC tryouts? Whoa. Has anyone attempted networking level 3? You have? Okay. Have you edited the config file for pfSense yet? No? Okay. Never mind. But like I said, everything in Linux is a file. There's this one giant file in pfSense that controls all the config. It's /conf/config.xml. Yes, question.
Is all of the systems config files still in
The question was, are all pfSense files still in PHP format? Yes, I have that same reaction too. All web files on pfSense are PHP files located at /usr/local/www. I'm actually going to show you where all the PHP files are as well and how to secure them. Now, accessing the GUI, when you log into pfSense via console, it'll display what interfaces it has, so a WAN and a LAN usually, and also the IP addresses associated with those. If you enter any of those IP addresses into a browser, you will open up the GUI. Note that in most competitions, you don't usually have a dedicated box with a GUI for the router. So you may have to go on a Windows machine and access the GUI from there, but you're gonna have to take over that box and also secure that, so keep it in mind. And fun fact about this page, the script that controls authentication to the GUI is at /etc/inc/auth.inc. There's one line, it's around line 2180. I do know it off the top of my head, unfortunately, that says if username in database and password equals database.getUser, something like that with the square brackets, you can just put in or password equals any value you want and it'll just let you in. You can authenticate to pfSense with with the password you set on any user if you just change that line. So auth.inc is on the GitHub. Learn the format of the file, learn how it works. You put it in a backdoor yourself or look to see if Red Team has a backdoor. So this is what you see when you first log in. This is index.php. Not a lot of exciting stuff on here, but it does tell you like the host name and the version, which the PHP files do change from version to version. So just check the GitHub, there's a drop down. They're all different branches of the repo. Now, managing users. If you go to this page, you can click into every user and see what groups they're a part of, what permissions they have, do they have an SSH key, is the account enabled or not. You can add your own users in here, remove users as necessary, but just as pfSense is built on Linux, these users are all in the /etc/passwd file or the etc shadow file. Now, on every one of these slides, I put the PHP file that is associated with it, because if you do, the URL as the IP address / the PHP file, it will bring up that associated page. If you see that all your menus are scrambled or they're in a different language, as long as the names on the Nginx server has not changed, you can access it directly. If all file names are scrambled, I am so sorry for you. Managing. Now we're going to go to managing all your interfaces. So here's where you can check the MTU value. I wouldn't touch anything in here really, because this is how your router is getting configured. But you can check if the interface is actually enabled. If that check mark at the top is not blue, that means it's down. Firewall rules. One thing to note about pfSense firewall rules is that it is applied per interface, and the rules only get triggered or evaluated when traffic leaves an interface. So if you have all your boxes, you're gonna have a cloud subnet and you're gonna have a LAN subnet usually, but you cannot control traffic between machines on the same subnet because it's never hitting the interface. It's just going to go directly to the other machines. What you can control is traffic into different subnets. So if you don't want your LAN boxes to access the internet, you can restrict that. If you don't want another service going to your cloud boxes, you can restrict that. Be careful with these because you can lock yourself out of boxes. But one thing to note, always remember that it's traffic leaving an interface. And here's some options. So in the GUI, you can set the action, set the interface. The GUI is pretty good at distinguishing what port and what service you want. So if you want to allow TCP SSH, that's port 22. You can do it by port or by a range of ports. You can apply it to a single IP, a range of IPs, or even tell it to go to this firewall, which is just the interface address as well. And again, PHP file, if you see a lobster riding a tricycle go across your screen, maybe try entering the URL instead of using the menu. Interface status, this is just basically a fancy ifconfig, but in the portal. I would focus on the in-out packets pass and the in-out packets block lines. That tells you if your firewall rules are working. So if you see a lot of packets being blocked, but you're like, I don't think I've blocked a lot of traffic, maybe reevaluate your firewall rules. System logs, pretty useful. Again, all of these are in /var/log. Yeah. But these, like I said, you are the first line of defense for your network. You are evaluating logs. If something suspicious is happening, it's mostly going to be network related, and you're going to let your team know so then they can finish remediating it. Backups. So like I said, everything in pfSense boils down to this one config.xml file. The GUI version literally copies config.xml into the /temp directory. If you know anything about the /temp directory, it's that it's temporary. It does not persist. So if you restart, your backups are not going to be there. I don't know why pfSense does that. It's a really great feature. So I just like to manually copy the config.xml file into another directory of my choice that Red Team doesn't know. But note that pfSense has a special log that tells you whenever the config file is changed. So if you use the head command, which just prints by default, the first 5 lines of a file, it'll tell you who last modified the config and when it was last modified. And some helpful diagnostics. These should be your best friend if you're using the GUI in competition. But everything can be done via the command line. One important thing to note, that diag_command.php file, if anyone has access to your GUI and they go to this page, they can run any command they want on your pfSense box as admin. And fun fact, if you delete this file off the system, so rm-f/user/local/www/diag_command.php, then no one can execute commands as admin from your GUI. It's amazing. But do make sure to back up all your GUI files first. You can edit files, but you can do that using VI on the system. Packet capture is just TCP dump. pftop, I usually have this open just as a separate terminal on another machine because this evaluates all the current flowing traffic. So if you see, oh, hey, Luke, I see this one weird IP address is going to your machine. Do you know what this is? And Luke's going to be like, I have no idea what that is. Maybe you should block that. Some tips and tricks. Back up all your GUI files. Know your baselines. Like, we're going to sound like a broken record, but if you know your baselines, it's going to save you a lot of time and stress from evaluating some red herrings. So what are the default services and cron jobs? I literally just spun up a fresh pfSense box, ran service tac e, copied all of them into a file. I looked at all the cron jobs, copied all the default cron jobs into a file so that I know there's this one cron job on pfSense. It's like NCKERNTZ. I had no idea what that is, my first competition, but it's legitimate, and do not delete it. Long story. But also, our API is supposed to be installed on a pfSense box. A REST API is how you can access the GUI essentially with just simple URLs. So if that's enabled, maybe look into that and keep track of how the router can be accessed. So is SSH enabled? Who can SSH? Again, you can view the SSH keys for every user in the GUI or in their home directory /.ssh directory on the system. And how can the SSH? That's checking the logs. Oh, that's an interesting note on the bottom there. Now we're going to go into some automation and scripting. So like we said before, your 5-minute plan should be knocking a bunch of the basics out because you want to save a lot of time for your digital forensics and your inject writing. On Windows, you'll have PowerShell or Bash scripts. Linux runs Bash. Note that pfSense is on FreeBSD, so it runs sh, not Bash. There is a slight difference in the syntax. You can also use, why is Java on there?
There's a question mark next to it.
You can, C++, really?
You can use anything. If you really aren't comfortable using shell scripting, you can use any language for scripting. I would recommend that you learn the native scripting though, for your machine.
But Python's really useful because there is an OS library, and it's also, you don't have to be on the specific OS to use Python. Ansible is the GOAT. You can automatically deploy scripts to a variety of machines, not just, so you don't have to go on each machine, get the script, and run it at the same time. But what should you be automating? Rotating passwords, inventorying the services, making sure that what you expect in the packet is there and configured. And now we're going to go to injects.
All right. The final part of blue teaming is going to be going over how to write a good inject. A lot of what we went over today was very technical and the technical aspects of working as a blue teamer. It's also a lot of non-technical aspects. And injects are one of the big non-technical aspects. In a blue teaming competition, you are an employee. You're simulating that you're an employee for a company, for whatever scenario that you're in. And one thing that employees get is work. And you will probably be given a good amount of work during the competition to do on top of securing these boxes, doing all of this technical stuff. You're going to have to worry about this. So learning how to write a good inject quickly will benefit you greatly. So this was said earlier, but what is an inject? They're business tasks that are given periodically during competition. Examples: perform a network audit, research a new technology, deploy a new security policy. These write-ups should be professional and submitted in a timely manner. Usually some categories for grading an inject would be timeliness, professionalism, and task completion. 2/3 of those are not related to the actual task. So even if you can't complete the inject before the deadline, just submit something professional. You can still get a good amount of points if you just submit something over nothing. Never don't submit an inject. If you're like strapped for time, you're trying to defend against a big red team attack, all your servers are down, trying to get some uptime, and there's an inject that's due in 10 minutes, and you feasibly just can't do it, write something and submit it. Never just leave it blank. In an inject, do not put sensitive information like passwords. If this inject submission were to get intercepted by red team, an attacker now has your password. So don't put credentials in an inject. And also some injects might not require a detailed report. Like if you have a meme inject at the end of the competition, where it asks you to create like a meme or like a joke or whatever for the end of the competition, and they don't ask you to write a report, you don't have to write a report. Or nothing super professional. So what does a good inject look like? So the first part of an inject is going to be a professional greeting. So this is going to be referring to your boss in a professional manner, like Mr. Smith. It's going to be having like a good subject line. It's going to be very professional in your greeting. For your executive summary, that's your next big section. You want to give an overview of the actions that you took at a super high level. so that a random non-technical executive could understand with business impact. So I should be able to give this executive summary to the CFO, and this person should be able to understand what I went through because it should be at a very high level. Make sure you also list business impacts about like how your operations are impacted by this inject. Next is going to be your technical details. This is where you provide the actual details of what you did with steps. Don't make it one big list. Make it like logically in paragraphs. Also reference images in your appendix. Speaking of your appendix, this is going to be where you include your screenshots. You want a good amount of screenshots. Not like 70 screenshots. Maybe like, depending on the inject, a good amount. Not one, but a couple. These should be all of the non-trivial tasks that you completed. So maybe unless it asks specifically for this, don't include a screenshot of like apt update, but maybe include a screenshot of you creating the user account. Obviously not with the password shown, but whatever the inject asks you to do. This is for proof that you actually did the task. You can say you did something, but with no proof, your boss cannot verify that you actually did that thing. These figures should all be labeled with figure captions, and you should reference them in your technical details. Here's an example of an inject you receive. If you know TCDC trials, this is Linux level 1. This is not what an inject will really look like. Usually it'll be more related to the lore of the competition. So like, heading over to set up a LAMP stack on our company winter servers. It is valid to understand how to configure commonly observed services. Blah, blah. It'll be something kind of like that, where like as you do something basically. And this is an example of an inject response about what a good one looks like. At the top, you have your professional greeting / header, where you have professional to from subject, professional greeting. Your executive summary should be a paragraph where you explain your technical actions at a very, very high level. Technical summary, again, you have to you want to reference your appendix. You want to explain the steps that you took to accomplish the task. Then have a really nice closing, professional closing, and labeled appendix with figure captions. At most blue team competitions, there will be incident response in some capacity. At a lot of RIT blue team competitions, this will be in the form of an inject that's usually continuous, meaning it'll be inject 0 due by the end of the competition. So you'll have access to it throughout the entire competition. Either a final inject or a continuous inject with incident response. This is where you document all of the malware that you found throughout the course of the competition. So it's important to maintain a document of screenshots for everything that you find so you can use them here. Hit all parts of the IR lifecycle, document how you came across the incident, how you contained it, what other things were related to this incident, how you eradicated the incident, how you recovered from the incident, and lessons learned. There will probably be a template that you're given that lists these out in really nice categories, so it shouldn't be too bad to format at all. There's the 1-10-60 framework: 1 minute to detect, 10 minutes to investigate, 1 hour to resolve. That should be your SLA. That's IR. Make sure you don't write IR reports on something that wasn't red team related. If you red teamed yourself, which you might do throughout the competition, don't write IR on that because you made the incident. IR should really be for red team actions on your computer. So verify that it is red team first.
All right, so some final tips and tricks before going into IRSec. You're doing IRSec next week. Don't stress yourself out. This might be the worst thing you do during competition. It might be even worse than letting your service go down, because stressing yourself out not only stresses you out, it stresses your teammate out. It stresses your teammates out. And you're not thinking clearly. So try to stay level-headed at all times. Divide and conquer. You should have people on your team that stick to specific things. If you're better at Windows, stick to Windows. If people are better at Linux, stick to Linux. Play around with the support services before comp deck. We've mentioned a lot before, getting familiar with stuff like pfSense, basic Linux services. Make sure you check the packet for the services and try and mess around with them. See how you break them, see what exactly, how they work. Try not to lock yourself out of your box, specifically your firewalls. Please test beforehand that it doesn't lock you out of your system. Don't taunt red team. Someone does it every single year and they always regret it. If you taunt red team, there might be a cow on your router. So don't do it. They usually have access to your box. And finally, know your teammates, know your strengths and weaknesses, know your role, similar to divide and conquer, know what your strengths are. Also, like Max mentioned, submit every inject, even if you don't actually do anything. Just having a professional note saying, hey, we weren't able to complete your task, you'll still get a lot of points for it. So to submit everything you can, know your resources, the store particularly. It will be an IRSX store. Know how to spend your points wisely. Know your baselines. Know what your computer is supposed to look like. Again, just making sure you play around with your systems beforehand, before the competition. You can't stress enough about that. Finally, have fun. Blue teaming is not a solo activity, so don't do everything yourself and be upset when you don't win. It's very much a team activity. So work together in this.
And one last note about injects. Yes, you should submit every single inject, but I will present the question is that should you do the task presented in every single inject? Just something to think about. If someone might be posing as your CEO, asking you to do a really security breaking thing, you might want to consider if you should do that, but you should still respond to it with some recommendations on how to proceed. Just keep that in mind.
Also, like in real life, like if your boss is asking you to do an action that you know would compromise the system security, you're allowed to say no professionally. So don't be afraid to say no if you believe that action that you would take would compromise your system. So, any questions? Yeah.
I had a question about scripting for CCDC. Do they let you have like Ansible that you can use to deploy scripts, or is that just for mainly black team?
Yeah, we have an Ansible. The question. Oh, sorry. The question was for CCDC, do we have Ansible that we use to deploy our scripts? The answer is yeah. We are for both Linux and Windows. We have Ansible for both of them. They have to be frozen 2 weeks before the first qualifier. But we're allowed to have them. We're allowed to deploy them. They have to be public, so other people can use our stuff if they really want to.
Are they deployed for you, or do you guys do that during the 5 minutes?
The question was, are the scripts deployed for us, or do we have to do them ourselves? And the answer is we have to do them ourselves. So that's why the 5-minute plan could turn into a 3-hour plan when things don't exactly go to plan. Back up. No. Sorry. Oh yeah, the question was for CCDC, do we obfuscate our scripts at all? And the answer is no, we're not allowed to. Anyone else? Any questions on boosting? Okay, cool. These slides will be posted, and there's some resources over here that might help you in your boosting competition. So thank you.